Hi guys, the topic we would like to share with you is humidification and its applications. I'm Cindy together with my teammates Zafran, Afif, Nabila, Noreen and Linquan are chemical engineering undergraduates. Well, before getting started, let's first understand what is chemical engineering. You might feel surprised that our study is not all about chemistry. In contrast, it's more focusing on mathematics and physics, maybe a little bit on biology. To be exact, chemical engineering is a study of chemical processes, design and operate chemical plants and methods of improving productions, further deal with related problems. We are not only designers but also problem solvers. Chemical engineers understand how to alter the chemical, biochemical and physical of a substance. Therefore, we are responsible for discovering safe and economic ways to change raw materials into desirable products while emphasizing on sustainability by protecting the environment. We are also required to equip ourselves with skills and knowledge such as chemical processes and kinetics, fluid mechanics, thermodynamics, plants and process design, mathematical modeling, material and energy balance, and programming to keep up with the Industrial Revolution. Well, what makes us different with a chemistry major? The chemistry major conducts experiments on a small scale in the lab to investigate the chemical reactions. On the other hand, a chemical engineer is responsible for scaling up the reactions. Chemical engineers' career prospects are wide. They can work in various fields like environmental, pharmaceutical, semiconductors, industrial chemicals productions, food processing, advanced material, oil and gas, and alternative energy.
What is humidification? It is an operation that consists of increasing the amount of vapor present in the gaseous current. The vapor can increase by passing the gas through a liquid that evaporates in the gas. This transfer to the interior of the gas stream takes place by diffusion, and at the interface there is simultaneously transfer of heat and matter.
To understand humidification, we have to first understand a psychometric chart. A psychometric chart is a graph of physical and thermal properties of gas-vapor mixtures, including wet bulb temperature. Firstly, the temperature we always understood is also known as the dry bulb temperature. A wet bulb temperature is the temperature measured by wrapping the bulb in a wick. Wet bulb temperatures are usually lower than dry bulb temperatures because the water on the bulb surface evaporates into the air. It requires energy to do that. That energy is known as the heat of vaporization. Let's consider two scenarios where two thermometers, both of them are reading 30-degree dry bulb temperature, but one of these is on a very dry day, while the other is measuring 30 degrees on a very humid day. Now both thermometer bulbs are wrapped with this wet cloth. For the dry day, the rate of evaporation of water will be very high because water is easier to escape into air. The more water escape, the more energy loss and the lower the temperature. For the humid day, water is not going to escape as much as on the dry day. The thermometer reading is not going to be as low. Actually, we are interested in the difference between the wet and the dry bulb temperatures. The bigger the difference, the drier the air. If there is zero difference, that will mean air is with 100% relative humidity. The air is saturated with water and no evaporation. Using psychometric charts, we can obtain the relative humidity and absolute humidity. Only 2 out of 4 these variables fully define the other 2, which cannot be directly measured.
These variables are used to design unit operation of humidification, such as this tower. For those who are not chemical engineers, they might think these towers are polluting the air because they are releasing tons of carbon dioxide into the atmosphere. In fact, they are not emitting carbon dioxide. They are cooling towers that releasing hot water vapor into the atmosphere. They are designed to cool down operation in chemical plants. Hot water is pumped to the top of cooling towers, then leave the tower and expel into atmosphere as vapor form. The wet bulb temperature represents the theoretical limit how much a cooling tower can cool water through evaporation. So, if wet bulb temperature on a given day is very high, it means the day is humid, and cooling tower will not operate well.
Outside of chemical plant, we can employ humidification knowledge into our daily life at home. Do you always feel hot during the day? Eyes are dry, cracking on the walls. These are probably due to less or too much humidity in the air. The solution to the problem is humidifier. If the water content in the air does not match what the humidifier owner has set, the humidifier will begin to operate to raise the water content in the air until the water content matches what the humidifier owner has set. A healthy humidity range is between 30% and 50%.
When there is a humidifier, we need a dehumidifier as well to alter and regulate the humidity in the air. A dehumidifier applies the dehumidification process, which is the inverse of adding water to the air but release heat instead to remove the excessive vapors. Therefore, an in-room dehumidifier will always warm the room and reduce the relative humidity indirectly and humidity more directly by condensing and removing water. But what do we use them for exactly in our daily lives? The small ones are usually for household stuffs, and the big ones are used in commercial buildings such as indoor ice rinks and swimming pools, as well as manufacturing plants or storage warehouses. So a dehumidifier works by drawing warm air currents into its coils via a vent. The warm air contracts as it's fed through the refrigerated coils of the machine, and condensation is left inside the dehumidifier. As this condensation collects, one droplet of water at a time, it falls into a storage tank attached to the dehumidifier. Cooler, drier air is then released back into your home through the other side of the machine. The dehumidifier should be able to bring the moisture in the air down to a relative humidity of 30 to 50%.
Next is application of humidification in refrigerator. Cold storage humidification helps in food and beverage humidification. When the warm fruit is placed within the cold storage, it warms the air that comes into immediate contact with the fruits. This warming creates a change in pressure as the air molecule expand, and the expanding air molecule now have increased the ability to absorb moisture. The moisture content of fruit is naturally high. Fruits and vegetables may lose moisture when stored at freezing temperature without a controlled humidity, resulting in loss of exterior qualities such as look, weight, and freshness. That is why humidification is important in this to control the relative humidity until it is in equilibrium with the product. Effective humidification benefits commercial market and supermarket chain such as chilled display cabinets and open counter, ensuring that the food quality is maintained throughout the supply chain. Usually, in the refrigerator, there are separate humidity drawer or crisper drawer. Most of it contain humidity vents that may be closed for high humidity or open for low humidity. The vents allow you to trap or release ethylene gas that causes your product to ripen too quickly. When you close the vent, you'll not only create a high humidity drawer, but you'll also trap the ethylene gas, preventing it from escaping and softening your other produce prematurely. The benefit of humidification in this application. First, raising the relative humidity inhibits moisture loss. Second, the right humidity level ensures that the product quality is maintained. Lastly, improved profitability through maintained product weight.
From the previous example shown, we know that the application of humidification is extremely useful and important in daily life. So that's all from us. Thank you for watching. Please like, share, and comment if you enjoyed our video.